So we're doing section 3.7, the homework. When we look at 14, it's f of x is equal to 3 plus x over x, 3 plus x over x cubed minus 27. Well, the first thing you do is you want to factor it, right? And we definitely, over in our scratch work, know that x cubed minus 27 is just x cubed minus 3 cubed. So using the difference of two cubes formulas, so the difference of cubes formula, I know I'm going to have an x and a 3, an x squared, a 3x, and a 3 squared. And we know that our signs are going to be the same as that negative, the opposite of this negative, and the last one is always positive. So that means when you factor it out, we're going to have x minus 3 times x squared plus 3x plus 9. So it's going to be the same. So it's going to be x minus 3 times x squared plus 3x, same, opposite, and always positive, plus 9. Okay? And so this binomial factor will never be able to be factored inside of the difference of two cubes. So if it asks us to find the domain, we set the denominator equal to 0. For the denominator equal to 0, we get this times this equals 0. So to find the domain, and so either this is equal to 0 or this is equal to 0. So you get that x is equal to 3, or I guess I'm going to have to do negative b plus minus square root of b squared minus 4ac all over my 2a, where a is 1, b is 3, and c is 9. And I think it's pretty clear that you're going to get what? Negative 3 plus minus the square root of 9 minus 4 times 1 times 9 over 2 times 1. So you're going to get 9 times 4 is 36. 36 take away 9 is going to be 27. But it's going to be negative 27. So these are complex answers, right? And so really the only numbers that you're not allowed to plug in here are x equals 3. So my domain's going to be anything but 3. So it's negative infinity to 3 and then 3 to infinity, because these complex numbers do not show up on this real number line. So that's your domain. Then what's the vertical asymptotes, the horizontal asymptotes of this function? So again, vertical asymptotes is where the denominator is 0. So this is going to be our vertical asymptote because it's where the denominator equals 0, right? So also vertical asymptotes. And then there are no holes, right? So the domain is denominator equals 0 because we didn't have any holes to cancel out. And so vertical asymptote is x is equal to 3. And then the horizontal asymptote, so our, maybe I write that down. Maybe I write down that vertical asymptote is where denominator equals 0. And we said that that's x equal to 3. And then the horizontal asymptote is what happens as x goes to infinity. So x goes to infinity, what happens? So for our function, it is Notice for our multiplied out original function, it's 3 plus x over x cubed minus 27. And what we know is, as x goes to infinity, x is going to dominate on top, x cubed is going to dominate on the bottom. So this thing wants to be this, which means in the long run, this is going to go to 0. So y equals 0 is our horizontal asymptote, right? All right. So that was 14. Let's look at 16. So if I look at 16, going on 17, I've got x squared minus 1 over x cubed plus 9x squared plus 14x. My biggest recommendation, and notice what we did here, is we always factor first. Anytime you're dealing with a rational expression, that seems like it's really helpful to always factor first. So over here, I'm going to factor first. I really want to see what the form of this thing is. Well, the top factors into this because of the difference of two squares. The bottom, if I take out an x, I'm left with x squared plus 9x plus 14. And so I think you can probably see that that is equal to, it's going to be an x, there's going to be an x, plus 7 and an x plus 2, right? And that's going to work out perfectly. So that ends up being what our expression is. Notice there are no common factors. There are no common factors, so there are no wholes, since nothing cancels out. So if we want to find the domain, we set the denominator equal to 0, or we worry about wholes. So denominator equal to 0 tells me that x times x plus 7 times x plus 2 must have been 0, which means this, this, or this. So I think that those are the three bad points. But notice they make the denominator 0 and they're not a whole, so each one of these is a vertical asymptote. So my denominator is not allowed to have 0, -7, or -2 in it, but you can be anything else you want. So it turns out to be -infinity to -7, -7 to 2, 2 to 0, and 2 to infinity. The union in between each one is what our domain is. So that is our domain. And each one of these is a vertical asymptote. Then if you ask me to find the horizontal asymptote, I think this form is better for reading horizontal asymptotes. So for the horizontal asymptotes, I think I'm going to put down this form and notice that f of x is equal to this. Well, this is approximately equal to, well, on top, this dominates as x goes to infinity. And this dominates as x goes to infinity. So it seems like it wants to be this for big x's, which means it wants to go to 0. So y equals 0 is a horizontal asymptote of this function. Cool. So that was number 16. So then we look at 20. So 20 wants to find the x-intercepts and the y-intercepts. Well, you know that the x-intercepts are where y equals 0, and the y-intercepts are where x equals 0. I would write that down every time I do it so that I don't screw things up. Well, let's do the easy one first. So the y-intercept is where x equals 0. For number 20, that means I simply plug in 0, and I get 0 plus 5 over 0 squared plus 4, or 5/4. So that means that the point 0, 5/4 is a y-intercept, right? Over here, the x-intercept is where y equals 0, so I take my entire y and set it equal to 0. But that only happens if the numerator is equal to 0. So the only way a over b, the only way a fraction can be equal to 0 is if the top was 0. That's the only way that can happen, right? So that means x must be -5. So that means -5 comma 0 is our x-intercept. So that's 20. If I look at 22, again, they asked for the x-intercepts and the y-intercepts. And every single time I write down that the x-intercepts are where y equals 0, and the y-intercepts are where x equals 0. So the easy one here is to plug in 0 and find the y-intercepts, where you're going to have 0 squared plus 8 times 0 plus 7. You're going to have 0 squared plus 11 times 0 plus 30. It should be clear that you just get those constant terms. So 0.7/30 is our y-intercept. Then we come over here, you set y equal to 0, just means we set our whole function equal to 0, but the only way that that can happen is if this is equal to 0. So that happens only if that equal to 0. And so if you factor that sucker, it factors into 1 and 7. So either this is 0 or this is 0, means -1 and -7 are our x-intercepts. So -1, 0, -7, 0 are our x-intercepts. That's 22. We look at 39. It wants us to find the intercepts, the asymptotes, and to graph that sucker. So for the intercepts, well, I think the first thing I'm going to do before I do anything is I'm going to factor that sucker out. So let's see what it is. So it's 2x minus 3 over x plus 4. I think it's factored completely. So always factor first if you can with a rational expression. So the intercepts, the x-intercept is where y equals 0. So I set my whole y equal to 0. And it tells me that x must have been 3/2. So 3/2, 0 is a point on the graph. The y-intercept is where x equals 0. So if you plug in 0, I think you get so f of 0 gives you -3/4. So 0, -3/4 is also a point on the graph. So I know 2 points on my graph. And why are they important? Because the x-intercept is where y equals 0, might be where something is hitting the ground, and a y-intercept is usually that starting value. How high up did it start? Or whatever else you may be modeling. Now, for our asymptotes, I know that the vertical asymptotes, that implies where's the denominator equal to 0. And so I take this and set it equal to 0. And notice here, you have to remove the holes first. Notice there are no holes because there are no common factors to cancel out. So then, only after checking for holes do you use the simplified version to set the denominator equal to 0. And we get that this is a vertical asymptote. Then for a horizontal asymptote, I look at my function, which is 2x minus 3 over x plus 4, and I notice that as x gets really big, 2x dominates on top, x dominates on bottom, and this thing wants to be 2, so y equals 2 is a horizontal asymptote. And now I'm ready to put all that cool information together in a graph up here. So when I do, I know that I have a vertical asymptote. X equals -4, a vertical asymptote. I have a horizontal asymptote. Y is equal to 2 is a horizontal asymptote. And what? I have the point 0, 3/2. So it's going to be here. So there's 0, 3/2. And I know that I have the point 0, I'm sorry, 3/2, 0. So this is 3/2, 0. And this is 0, -3/4. So it looks like this thing is going to do that. Looks like this thing is going to do that. Right? How can I verify that it's going to go down here to -infinity? That's because it had to either go, so I've got this 0 here, yes? So I know that it can't go back up this way because that would create another 0. That's why I know it has to go down to -infinity. This one here, I know it has to explode up because if it exploded down, it would create another 0, but this is the only 0 I have. Cool. Awesome. So that was was that 22? No, that was 22. That was 39. So that was number 39. After 39 is 41. So 41 is S of x is equal to 4 over x minus 2 gets squared, right? So if I had to go through all the whole things again, first, it's already factored, so we always factor first if we can, so it's factored. And we see that there are no holes because nothing cancels out on top and bottom. So if they want first the vertical asymptotes, well, the vertical asymptotes are where you set the denominator equal to 0. So we get this thing equals 0, which means x is equal to 2 is a vertical asymptote. For the horizontal asymptote, you should realize that this is just the same as 4 over x squared minus 4x plus 4. So in the long run, as x goes out to infinity or -infinity, so all of these I could have put as x goes to either positive or -infinity, right? So this one I could have put, let's go back here. I could have put as x goes to either positive or -infinity. Same thing for this as it goes to positive or -infinity. It doesn't make a difference. Sometimes it will make a difference, but in everything we've done so far, it has not made a difference. So here, if you either go to positive or -infinity, the top wants to be 4, the bottom wants to be x squared, that just goes to 0. So a y equals 0 is a horizontal asymptote. Then let's do our intercepts. So my x-intercept is where y equals 0. So take my whole function and set it equal to 0. You notice that the only way that that can happen is if the top is equal to 0, but that means that there are no x-intercepts because 4 can never be equal to 0. The y-intercept is where x equals 0. So we simply plug in 0, and f of 0 gives you 4 over 0 minus 2 squared, which is 4 over 4, which is 1. So 0, 1 is our y-intercept. Again, notice there are no x-intercepts. It never crosses the x-axis. It only crosses the y-axis. So when we graph this sucker, we have a vertical asymptote at x is equal to 2. It goes to the point 0, 1. It has a horizontal asymptote at 0 that way. So it's got to blow up this way because it can't go down this way because it created an asymptote. And in the long run, it wants to be 0 over here. Again, it's got to explode up because it cannot create another, or it can't create any x-intercepts because we know there are none. So that's what it looked like. Another way to think about this is it's 1 over x squared, where you simply shifted it to the right. Simply shifted it to the right, and then you scaled it by a factor of 4. So I would expect it to look like this. That's 41. 43. 43 is f of x is equal to over, this is 43. Okay, so it looks like this, right? So I'm going to try and factor this sucker first. I know it's going to have this and an x, and I know this is probably going to be a 5 and a 1. And that works out because I need 15 and 1 to get me 14. Since it's negative 14, I want this to be negative and this to be positive. And that's going to give me all the correct terms I want. I know this has got to be 3x and 3x because this has to be the product of those. Then this, maybe it's going to be 8 times 2. Maybe it's going to be 4 and 4. Maybe it's going to be 8 and 1. Let's try 4 and 4 is 16, right? Then there's 12 and 4, and that can get me the 8 I need in the middle. So I'm going to make, one of them has to be negative. I'm going to make it this one and this one positive. So that's going to give me 12 minus 4 is 8. This is negative 16, and that's 3, so everything works out perfectly. Okay, notice nothing cancels, so there are no holes. And so now we're ready to rock and roll. So the x-intercept is where y equals 0. Well, that's only going to happen if the entire thing, the entire y, is set equal to 0. But that's only going to happen if, that happens only if the top is equal to 0, which means this equals 0 or this equals 0, which means you get 5 and negative a third are our two x-intercepts. So that means negative 1/3, 0, and 5, 0 are 2 points on our graph. The y-intercept means that x is equal to 0. So if you plug in 0, you're going to get 1 times negative 5. On the bottom, you're going to get negative 4 times 4. So it's going to be negative 5 over negative 16, which is 5/16. So 5/16, 0, 5/16 is a point on the graph. Our vertical asymptotes, so our vertical asymptotes, in this case, are going to be where the denominator equals 0 for our rational expression. So I said the bottom equal to 0, and that means either this equals 0 or that equals 0, which means we have 4/3 and negative 1/4 are two vertical asymptotes. But then for my horizontal asymptotes, I look at my function, f of x, which is 3x squared minus 14. boop, minus 14x minus 5 over 3x squared plus 8x minus 16. As x gets really big, this thing wants to be 3x squared over 3x squared, which is 1. So y equals 1 is our horizontal asymptote. So we should be able to put all that together to draw a pretty picture. So first, I've got 0, 15 over 16 is right there. I've got negative 1/3 0 and 5 0 as my only zeros that you ever see, right? And then I've got a vertical asymptote at positive 4/3. So here's 4/3 is a vertical asymptote. And negative 4. Over here is negative 4.